Hey, I'm Marty, and welcome back to the SDL C++ 2D platformer. So this series is all about making a 2D RPG with the core gameplay mechanic being physics-based 2D platforming. So we're going to have quests, all the lore that comes with games. So this is part 3. Now, if you have not set up SDL yet, I highly recommend you do that, otherwise you won't be able to use SDL and follow along with this series. So part 1 in this series will show you how to set up on Windows. Part 2 will show you how to set up on Linux. Other than that, nothing else to report besides the fact that I combed my hair, which is a very rare occurrence. So why did I comb my hair? I don't know, just felt like it. There's a time and a place to look like a ragamuffin, and I wasn't too keen on putting out the vagabond vibe. I gotta look somewhat professional here, although I'm not monetized. In the last 2 videos, I was fairly brief with everything because we're just setting things up, and I didn't want to spend too long on the little details such as why I have to add certain things to Windows environment variables and stuff like that. Now for the rest of the series, I'm going to go at a bit slower pace so that we can get a full understanding of how each line of code works and what exactly is going on. So let's open up our project file. In our project directory that we set up in the last 2 videos, we're going to have this SDL2 platformer sublime-project file. So right click it, and then go open with Sublime Text. And if we go along our folders in the side, we go source, we'll notice we have a main.cpp. And so far, all we did was just hashtag include SDL and SDL image and then print out a message. So all of this code is going to be exactly the same if you're on Windows. I'm on Pop! OS, but I've already tested and I know for a fact that this works on Windows. All right, so let's go over what we have so far. So right now we have hashtag include SDL, and then we also have this hashtag include SDL2 SDL_image.h, and this hashtag include stream. Anytime you see a hashtag include, it's just saying we're going to import a library, which a library is somebody else's code essentially. So we're going to take somebody else's code that they've worked hard on, in this case SDLs, and we're going to import it so that we don't have to rewrite a rendering system. Essentially, hashtag includes make our lives a lot easier by giving us access to libraries. Next, we have this int main. So this is a function, but it's a weird function. It's an oddball because it has this little name called main. Anytime you have an int main in C++, that is the entry point for the program. So that's where the program actually starts. When we run our program, it jumps straight to here, and that is where everything starts happening. So far, so good. And these here are arguments, so we can pass those to functions and say, hey function, here's a few things you might need to get started. In this case, the arguments are necessary. I typically don't use arguments like this, but in the case of SDL, they are required. So make sure you have those int argv and int args. I think it was argc, actually. Is it supposed to be c? I don't know. I don't use it that often, so it's hard to tell. So let's get rid of this print statement, which just prints out some wonderful stuff. Just gotta move this mic real quick so I can actually type, because otherwise I'm going to be going crash, bang, bang. Now let's throw a return 0 right here. Now you may have heard in modern C++ you don't need the return 0 if you're dealing with int main. However, SDL is just the guy who won't do things the way everybody else does. Why is it like that? I don't know. It's like the kid in class who always had to pick their nose. Oh, it's disgusting. It's like, don't do that. Pick that somewhere else. But the point is, we have to have this return 0. And that's because SDL initializes by hooking into our main function, which is an odd thing to do. Anyways, we can work around that. So now that we got our return 0, we can actually start writing some code. The very first thing we're going to want to do is go if. So we're opening up a if statement, which if statements are basically how you solve logic. This controls the flow of your program. So you might hear some people call these things control flow statements because this directs your program to certain things. So you can say if Mario's a little bit bunged up, Mario.drink some prune juice, things like that. So that's how our logic kind of works. So in this case, we're going to go if SDL_init, open up some parentheses, if SDL_init, and then SDL_video. If that is greater than a 0, then we got ourselves a little problem. Hit enter, open up some square braces, and inside here, we're going to do something if this happens. So what's actually happening is we've just called a function, and this function is SDL_init. Now, SDL_init returns a value. The value is 0 if everything worked right. So that's why we say if it's a greater than 0, then we're going to print something. Then we got ourselves a problem. And in that case, we're just going to print a nice little message by going std : cout, open up some angular brackets, open quotes, and inside there we're going to say, hey, SDL_init has failed. And the reason we're going all caps for this message is because this message is kind of aggressive, has tyrannical tendencies, so it has to assert its dominance by yelling at everybody. So that's why it's all caps. period, and then SDL underscore error, add a colon, and then add a space, open up 2 more angular brackets, and inside there go SDL underscore get error. And then add 2 more angular brackets, and then go std colon end l. So this right here ends the line. This right here is a call to a SDL function, and this is going to return the last error that has happened regarding SDL. Control save that, go tools, and then build system, select debug, and hit F7 to compile and run this, make sure it works. Bingo. So it says right here, finished in 2.9 seconds, which is pretty fast. I mean, it's a lot faster than I could compile it. So now that we've got SDL initiated, we're going to want to also initiate SDL underscore image. So go if, pretty much the same thing, if img, and then underscore init, open up some parentheses, and then go img init underscore png. Or actually, this should be if that is not happening. So add a exclamation mark, and the reason we use exclamation mark here is because it says it's the not operator. So meaning if this command right here fails, well, we got a problem. So in the event that this fails, we're going to print another error message, std colon co. Now you may be thinking, isn't all this printing stuff kind of a waste of time? Wouldn't it be a lot faster if we just went through this and just went image underscore init? And that's a good point until something goes wrong and then you can't quite track down where it goes. In the event that we cannot load SDL underscore image, we're going to go image underscore init has failed. And then error, add 2 angular brackets, and then go SDL underscore get error to get our lovely error that is very vital to this program. It's our error serum. We need it. And then go 2 more angular brackets and then std colon end l, which is to say end the line. Now you'll notice right here, I did not use any more squirrely braces, which if you have a one-liner inside an if statement, you don't need the squirrely braces. Now we've got SDL image set up. Now this flag right here is actually a enum, which an enum is basically just a couple of integers that have been given names. So in this case, we're passing it the enum image underscore init png to say, hey, SDL underscore image, can you get us set up with some PNGs, which is a file format for textures. In this tutorial, we're just going to be dealing with PNGs. If you want to use something else like BMP, completely up to you. You just got to have the BMP right here instead of PNG. Alright, so the next thing we're going to do is we're going to create ourselves a class. So go Control N, and we're going to create this class in a separate file. So right now we've got our main.cbp. We're going to create something else .cbp with a twist. It's going to be a .hpp because it's a header file. And then we're going to start by going Control Save, Control S to save that. And we're going to save that in include. So save that in include and title it render window.hpp. Hit enter, and we have just successfully created our very first header file. If we check our folders along the side and open them, we'll notice we now have render window.hpp in the include folder. The very first thing we want to do in any header file is go hashtag pragma once. This ensures that a header file does not get copied twice, because header files, that's all they do. If we write something like AAAA, and then we go into main.cbp and we include that header file with hashtag include, open quotes, render window.hpp, we've essentially just wrote in AAAA right here, because that's all it does. This right here goes, hey, Control C, all of this, and paste it in right there. Because it essentially just copy and pastes, we need to ensure that it does not copy and paste twice to the same file. So that's why we have the pragma once. The second thing we're going to do is go hashtag include. So get ourselves a nice little library, open up some angular brackets. Now you'll notice that we're using angular brackets in include. You can use angular brackets and you can also use quotation marks. It works exactly the same. I use angular brackets for header files that aren't my own, so I have not written them. And then files that I have written, then I use quotations. So this way it just keeps it clear what is actually mine, what I'm working on, and what is actually a library. So open up some angular brackets, go SDL and then / SDL.h and hashtag include SDL / make sure it's SDL2. So and then SDL underscore image.h. Hit enter. Now type class. So we're going to create a little class and we're going to call it render window. Hit enter. Open up some curly braces. Add a comma to the end of a curly brace. So this is essentially how you set up a class with C++. Hit enter inside those curly braces and then type public, add a colon, hit enter, and then type private. Add a colon and hit enter. So these two things are called access specifiers, and access specifiers is essentially like washrooms. So a public washroom is available for anybody to use, and a private washroom like the one in your house is available for only your house to use. That's essentially it. So in the private section, in the little section that is taped off from the public access, we're going to create two variables. So the first is SDL underscore window, and then add a asterisk, which is to say make this thing a pointer, make that variable a pointer, then window. Add a semicolon. This right here is our window that we'll draw to. So this is actually the window you see. Similar to how we have a window right here with Sublime Text, well, we're going to have our very own window with our program. To enter, go SDL underscore renderer this time, renderer pointer, and call it renderer. Now this renderer doohickey is basically a thing that turns all of our game into something we can display to the screen. So we can render textures to this and mess around with the textures. Then the renderer is going to rasterize that into pixels that can display onto our window. This renderer uses OpenGL. You may have heard of it before. Now the pointer might throw you off because you're like, what is a pointer and what on earth is it doing in our program? Essentially, think of a pointer like an address to somebody's home. So variables are things like integers and floats. We go int variable, whatever it is, int var equals something like 5. So variables are like houses. They're a house, a hoose, if you're in Saskatchewan or around the area, you might say it like that, or if you're just in Canada. Right? So the house in this case stores 5. So inside this house, there's the number 5. Variables, or these houses, live down a little lane called a RAM, which is random access memory. Let's say we have two parts of our program, two different functions. So we got this little part 1, and we have part 2. So function 1, function 2. Function 1, we have a house right there. We got our nice, quaint little shanty. Doesn't look like a house, looks more like an outhouse. So let's make it an outhouse. There we go. That's much more realistic. So function 1, just call it func. Guys, my handwriting is really a lot better than this in real life. It's just hard to draw with a mouse. It's very difficult. So func1 has this nice little house, and it's our int variable equals 5. Now let's say function number 2 needs this variable. How do we get this variable? Well, that's why we have something called a parameter. So the parameter can warp right through this barrier, through a little wormhole right here. It can worm right through via a parameter. This parameter warps this house right through. Now, this is actually kind of slow because we've got this house here, which is equal to 5, and we also got this house here, which is equal to 5. They're both equal to 5, so why do we need two variables that are exactly the same thing? The answer is we don't. So we need a different way of going about this other than picking up little Tommy's home here and transporting it all the way to function number 2. There is a different way, and that is we can actually get the address of where this house is, the mailing address, or if you're speaking in computers, the memory address. So we take that memory address, which is where the pointer comes into play. The little pointer says, hey, don't copy this variable. Just take the mailing address of this house, send it to this function, and then once here, we can just send letters back and forth to this variable right here, or this house right here. So that's essentially how pointers work. If you want to go more in depth, which I recommend you do, there's videos by the Chernal Project and Bucky's C++, and they're very thorough and they make a lot of sense. So that's a brief explanation. That's why we got the little asterisks. So those are the only two variables we'll have for now, and these variables are pointers. So they're pointers because we're going to create a SDL underscore window, but it will not live inside this render window class. It's going to live somewhere else, wherever SDL wants it to live. So we're just going to get the mailing address or the memory address of where that variable lives, and then that's how we're going to use it. So then we're going to get a little correspondence going between that variable. So in the public field, type render, I got caps lock on, don't I? There we go, you old rascal, caps lock. Caps lock render window. So what we're doing here is we are creating a constructor. So this is a function essentially, and it's a special function because whenever we create a class render window by going render window winders, this function right here will get called. So basically, whenever we create a render window, this function will get called. We're going to give it a few parameters. The first is a constant character pointer, and this will be p underscore name. Perhaps let's call it title. So we're going to title our window like we have a title right here for Sublime Text. We're going to do the same thing for our epic game. Constant character pointer is, without getting too deep on it, it's essentially just a quick little string. It's a quick throwaway string. You don't do much with it. Doesn't have a lot of functionality. It's just there to transport characters, which characters are words and numbers too. anything inside quotations is a character of sorts. So that's what we've got there. And then we're going to go int p underscore width w and int p underscore height. So you may be wondering what is going on with that p underscore. This here is mostly just preference. This p underscore just says this is a parameter. So go control in. So now that we have a header file, we need to fill that out with a source file. So inside this new file with control n, go hashtag include, and actually just go back to render window and copy these two lines right here. Control C, copy that, include SDL and SDL underscore image. Now you may be thinking, hold on, this is a header file, and if we include the header file, which we're about to do with hashtag include render window.hpp, if a header file essentially just copy and pastes, won't we have duplicates of this hashtag include right here? And yes, we do. That's why header files have the hashtag parameter once, to make sure that it does not get copied twice. These two lines right here aren't necessary. You can do without them. It's up to you. I typically like to include them even if I don't have to include them, just to remind myself of which libraries I'm using in this certain source file. So control shift save that as, save it in source this time and call it render window.cpp. Hit enter and then type render window : render window. So what we're doing right here is we're saying, hey, there is a function inside of the class render window and its name also is render window. We're going to fill out that declaration with body, and we had a constant character pointer p underscore title, and we had a int p underscore width, so the width of the window, and int p underscore height, the height of the window. Hit enter and open up some curly braces. Inside there, open up an if statement and go if SDL underscore create window. And inside there, we're going to give our p underscore title. So we're going to name that, add a comma, and then go SDL underscore win pos underscore undefined. So this right here just says, hey, SDL, you're going to pop this window up somewhere. It could be here, could be there. So this is for the X position, and this is for the underscore Y position, which is the same thing. Add a comma, and then go p underscore width first, and then p underscore height second, and then comma SDL underscore window underscore shown. Oh, hold on a second. We got our debugging backwards. In this case, we don't actually have to use the if statement. We can just leave it like so. This function here returns a pointer to a SDL window. So in this case, we go window equals, to be clear, this is one line. Window equals SDL underscore create window. Now, how can we test if this actually worked? Well, what we can do is add a colon here, and let's first set our pointer to point to nothing. It's going to be a null pointer. To do that, we're going to use a member initialization list, and we do that with a colon right after this closing parenthesis, and we go window and then open up some parentheses, and inside there type null. Add a comma, and we're going to do the same thing for renderer. Set that equal to null. And now what we can do is we can go, if our window is equal to null, meaning it's still pointing to nothing, and this command right here is not returned a valid memory address, well, then we're going to print out a little error message. So open up some square braces, and inside there we're going to go std : cout window failed to init. And then our error will be a good old healthy dosage of SDL underscore get error. And then we'll end the line with the std : nl. All right, and that is going to initialize our window. Hit enter and then go renderer equals SDL underscore create renderer. So we're going to say, hey SDL, can you create us a renderer? And then the SDL is going to say, okay, but where do you want to render these images to? Well, render them to our window. Now the second parameter is a index to a graphics driver. We can actually avoid messing around with that if we just go -1, which is going to say use the first one that satisfies everything we're going to need for our drawing operations. The third and final flag is SDL underscore render underscore accelerated. So this final flag says, hey SDL, if there's a graphics card installed on this computer or Xbox or PlayStation, whichever we're distributing to, use that graphics card because it's probably going to be a little bit faster than our CPU. Essentially, it says, hey SDL, go as fast as you can. Control save that, and that is everything we need to do in our render window function. Control save that render window.hpp, and then go to main.cpp, and right after we initialize SDL, we can actually create our render window with render window, and the parameters that we told it to ask for is going to be our title. In this case, we'll call this game, and let's say version 1.0. How big do we want the window to be? Let's go with a nice 2080 by 720. Add a semicolon to that, control save, hit F7 to make sure we don't have any errors, which we do. So go to renderwindow.cpp, that's the source of our troubles for the compiler, and add a new include, which this is going to be hashtag include iostream is to print things to our console. And we're trying to print right here, but we haven't said, hey, we're going to need printing stuff. The next one is this WinPos. It's actually window pos. And again, a window pos. The next one is this render accelerated. So control save that with the new changes, hit F7, and it should all work. No, I still managed to misspell all this. Okay, missing one little E. I mean, that's a lot of E's. Like, how many is that? 1, 2, 3. Hit F7, and now it all should work. Hey, it does. And if we noticed, it went pop. So we created a render window, but we haven't told it to stick around. We've just said create it and then destroy it as quick can be. All right, so now that we created this window, we actually have to destroy it ourselves. Otherwise, there's a good chance we could get a memory leak of sorts. Most variables will actually be deleted at the end of the program for you, but in some cases, you have to do a little bit of work. So go to renderwindow.hpp, add a void. So a void is a function that does not return anything. And we're going to go clean up. Normally I'd use a deconstructor for things like this, but in this case we're gonna risk it. We're gonna go rogue. And so go back to renderwindow.cpp, and now we're gonna add a body to our definition of our function. So hit escape to get out of that debugging stuff so we have a little more real estate to work with, and then go void render window. So render window colon and then clean up. So what's going on with this little colon stuff is we use the unAreaScope resolution operator, which essentially says, hey, class render window, I know you've got a little function and it's called cleanup. Now hand it over so we can mess around with it, and which we will do with just SDL underscore destroy window, and we're going to destroy our window. So control save that. That is all good to go. Go to main.cpp, and then right before we go return 0, we're going to go window.cleanup. So we made a little window mess, we got to clean it up, and then go SDL underscore quit. So if we go control save and hit F7, we now have a well-behaved program that's doing everything the way it should be. So now let's actually create a game loop so that our window sticks around. So to do that, we're going to create a Boolean variable here called bool. So bool, it's a Boolean, and Booleans can be either true or false. Game running. So bool game running, and then we're going to create a while loop. And then after that, we go while. So a while loop will run forever and ever until a certain function is no longer met. So as long as if our game running is equal to true, so we gotta say, hey, that's true. While game running, open up some curly braces, and inside those curly braces, this is going to be our actual game loop. So this will run infinitively until this condition is no longer met. So we need some way of determining if we actually still want to continue running the game. The way we do that is we could just take a guess and say, I guess we shouldn't be running the game, but that's guaranteed to break. So let's be a bit scientific, and we're going to create a SDL underscore event. So this says, hey class, SDL underscore event. Let's create ourselves an event. So now we want to go while. So we're creating a while loop within a while loop, which is a bit like Inception. So then we go SDL underscore poll event. So while we're polling for event with the memory address of our event, so the mailing address of our event, while that happens, we're going to test a few different things. The first test we want to do, if event.type is equal to SDL underscore quit. If that is true, then we're going to set game running equal to false. So we will no longer run the game. If we go control save, hit F7 to run this, you'll notice now it sticks around a little. So we can wiggle it. We can we resize it? No, we can't. But we don't really need to resize it for our particular game. We can wiggle it and we can close it. And once we close it, it says finished in 12 seconds. Alrighty, so that's where we're going to leave today's episode. I hope you enjoyed. If you have any questions or comments or anything to say, just let me know down below. Make sure you subscribe and code like. Thanks for watching, and I'll see you next video. Right after a quick word from our sponsor. Get your McVanBuck Trophy Mosquito. McVanBuck Trophy Mosquito is a hilarious humor story. It's a collection of 3 stories written by my dad. It's highly entertaining. It's all 100% clean humor, and it's written by my dad, Peter and Mast. It's a prelude to a bigger book to come that will be released shortly here. So let's just have a quick little read. As the water splashed upon Grandma Jay's feet in the kitchen, she gasped with really big eyes just staring at me. Water? What the water? Ah! It must have been the shock of the cold water hitting her toes that made her jump and lose her words. It always made me lose my breath too if the water in the pool was that cold. So I'm going to be giving away 10 of these free, and there's still 10 left. Nobody has asked for any, which this is good quality. It's free. All you got to do to claim it is just send your mailing address to codergopher@gmail.com, and you will win a free McVanBuck Trophy Mosquito. Limited edition. There's only 300 of these made. It's complete with illustrations and everything you'd want for a good sit down and a nice read. Laughter is guaranteed.